NASA has just confirmed something straight out of a science fiction movie. A black hole is on a direct course toward Earth, not an asteroid, not a comet. A real black hole traveling at 150,000 kilometers per hour. The kind of thing that bends light, eats stars, and turns entire planets into dust within minutes. The internet collapses under panic. Hashtags like Goodbye Earth spread everywhere. News anchors try to stay composed while memes flood every screen. Governments call emergency meetings. Scientists stay awake for days, running every simulation they can. And every result ends the same way: Earth disappears into darkness. The clock is ticking. 72 hours left before gravity itself becomes our greatest enemy. Yet in the middle of global chaos, humanity refuses to sit still. Instead of giving up, the brightest minds on the planet begin to think about how to strike back. A question rises above the noise. If a black hole can consume everything, could something exist that consumes it? Could we blast it, collapse it, erase it from existence? No one knows the answer, but no one stops asking. The world unites under one impossible goal: destroy the most unstoppable force in the universe. This is not science fiction anymore. This is the biggest headline in human history. Earth versus the black hole. The moment the black hole enters our solar system, the universe starts to look wrong. At first, it is Neptune that feels it. The planet's perfect blue orbit shifts, just slightly, like a coin spinning off balance. Astronomers notice before anyone else. Then the sun itself begins to tremble, its surface rippling as invisible waves of gravity twist the light around it. Even from Earth, the night sky starts to shimmer strangely, like heat above asphalt. The moon shakes. Tides on Earth rise hundreds of meters higher than usual. Entire coastlines vanish under walls of water. It is not because the moon has changed, but because gravity itself has. The black hole's pull stretches space like a rubber band, and everything inside that band, from oceans to cities, moves with it. Scientists call this tidal disruption, but you do not need to know the name to understand it. Imagine your body is caught halfway between two magnets pulling in opposite directions. One part of you wants to go left, the other wants to go right. That is what happens to everything near a black hole. Matter stretches like spaghetti, a very dark, very final kind of pasta. NASA's best computers try to predict the path. They calculate that the black hole might only pass by about 15 million kilometers from Earth, a close call but not a direct hit. The problem is that space is not a racetrack. A small shift, even 1% of that distance, could send the black hole straight into us. The world goes silent for a few seconds, then explodes into chaos. Every nation capable of launching anything into orbit joins a single desperate plan, codenamed Project Oblivion. The goal is simple: throw everything at it. Nuclear warheads, orbital lasers, even experimental antimatter capsules. Every weapon humanity has ever built is turned toward the dark dot no telescope can truly see. Soon the sky becomes a storm of fire. Thousands of rockets streak upward, leaving trails of light like glowing scars across the atmosphere. For a brief moment, hope looks bright. Then, as the explosions fade, sensors pick up the result. Nothing. The black hole does not flinch. It does not glow. It does not break apart. It simply swallows everything: energy, debris, light, and grows. The realization hits all at once. Every ounce of energy humanity just fired added to its mass. Einstein's old equation, E equals mc squared, suddenly feels cruelly literal. Energy turns into mass, and mass turns into more gravity. The more we fight it, the stronger it becomes. Scientists stare at the readings in silence. Project Oblivion, the biggest act of defiance in human history, has become a cosmic feeding session. Someone mutters what everyone is already thinking: humanity just threw gasoline on the biggest fire in the universe. The failure of Project Oblivion sends shockwaves through every lab and command room on Earth. The black hole didn't even blink. It simply absorbed humanity's greatest display of power like a snack. But if brute force won't work, then maybe something smarter or crazier will. The world's scientists turn their attention to the only person who ever hinted that black holes might not be eternal: Stephen Hawking. Decades ago, he proposed that black holes aren't completely black. They slowly leak energy, like a tiny campfire giving off heat, a process now known as Hawking radiation. In simple terms, it's like this space isn't empty. Tiny pairs of particles are constantly popping into existence and disappearing again. If that happens near a black hole, one particle might fall in while the other escapes. The one that escapes steals a bit of the black hole's energy, making it ever so slightly smaller. So the new plan is bold and simple: make the black hole evaporate faster. Supercharge the effect. Massive laser grids are built in orbit, each the size of a small city, all focused on the dark patch of space where the black hole lurks. The idea is to flood it with radiation, force it to emit more energy, and slowly burn itself out. For days, the lasers fire. It's the most intense light ever produced by human hands, a blinding halo around something that doesn't even reflect light. And yet, the sensors show nothing. The black hole is far too massive. Hawking radiation works only on microscopic black holes, the kind that might weigh as much as a mountain or less. This one is millions of times heavier. Trying to make it evaporate with lasers is like trying to melt an iceberg with a candle. But humanity doesn't stop there. If radiation can't destroy it, maybe its opposite can. Enter the Antimatter Project, a global effort to produce and weaponize the most volatile substance in existence. Antimatter is like the mirror image of regular matter. When the two meet, they annihilate each other completely, leaving behind pure energy. In theory, a gram of antimatter could release as much energy as a nuclear bomb. So what happens if you throw tons of it into a black hole? Production begins. Every particle accelerator on Earth works non-stop. Antimatter is stored in magnetic bottles, carefully kept from touching the walls. The plan launched the payload directly into the black hole and trigger an annihilation reaction so violent that it might tear the horizon apart. Launch day comes. 100 rockets, each carrying a few grams, leave Earth's orbit. Humanity watches in silence. Seconds turn into minutes. Then, one by one, the antimatter capsules collide with the event horizon and vanish. There is no explosion, no flash, no sign of damage. The black hole simply absorbs the antimatter, just as it did the nukes. The total mass goes up again. For a moment, everyone stares at the monitors. Then laughter breaks out, the tired, desperate kind. The universe doesn't play by our rules. The summary report is short and brutal. Lasers failed, antimatter failed. Hawking's theory is correct, but useless at this scale. The black hole is still coming. But even as the world begins to accept defeat, there's a whisper among the scientists. Maybe the problem isn't that we're too weak. Maybe we're attacking it the wrong way. What if, instead of trying to destroy it from the outside, we could disrupt it from within? A new plan begins to take shape, one that dives straight into the heart of the most dangerous object in the universe. When every weapon fails, humanity does what it always does best: it dreams bigger. The missiles and lasers are gone. Now it's time for the impossible ideas. At CERN, the world's largest particle lab, a new theory takes shape. If you can't destroy a black hole with bombs, maybe you can bend space itself. The team calls it Project Planck, named after the smallest possible scale in the universe, where space and time stop behaving normally. To even get close, you'd need something called Planck energy, a number so huge it barely fits on a calculator, 10 to the power of 19 giga-electron-volts. For anyone not fluent in physics, that's roughly 1 billion trillion times more energy than the Large Hadron Collider can produce. In simple terms, if the LHC is a flashlight, Planck energy is the sun. The theory says that if you could reach that level of power, you might be able to twist the fabric of space-time, the invisible sheet everything in the universe sits on. The hope is that by twisting it in just the right way, the black hole could collapse or unravel from within. The problem: you would need the total energy output of the sun to even try. One wrong calculation, and instead of bending space, you might tear it. But by now, humanity isn't worried about being careful. One team proposes using a neutron star, one of the densest objects in the universe, as a kind of natural power plant. Compress its matter enough, they say, and it might create a gravitational mirror to reflect the black hole's pullback at itself. It sounds poetic. It also sounds insane, because compressing a neutron star even slightly can make it collapse into another black hole. In other words, your plan to destroy one black hole might end with two. Still, the race continues. Scientists start talking about something stranger, the information paradox, according to modern physics. Black holes might not erase what they swallow. Instead, every atom, every photon that falls in leaves behind a kind of fingerprint in the radiation that escapes. It's as if the black hole hides the information in a code too complex for us to read. The new plan is simple in concept, impossible in practice. If you could decode that information, you might understand how a black hole stores everything it eats. And if you understand that, maybe you can take it apart from the inside out. So humanity builds its boldest mission yet. A spacecraft loaded with a quantum supercomputer is launched straight toward the black hole. It's not carrying bombs, it's carrying algorithms designed to hack the structure of space-time itself, from Earth. Millions watch the feed as the ship drifts toward the glowing edge of the event horizon, the point where not even light can escape. The last signal received is a steady tone, then silence. For a while, no one says anything. The data stops, the telemetry vanishes, the ship, the crew, the supercomputer gone. Some scientists whisper that maybe the ship succeeded, that maybe it found something inside and is sending information in a form we can't yet understand. Others say it was simply torn apart, stretched thinner than atoms. Whatever the truth, the mission leaves one haunting line in every report. Once you look into the abyss looks back, and the black hole, still growing, still moving, continues its silent approach. Every plan has failed. The nukes, the lasers, the antimatter, even the dream of creating a white hole, all gone. The black hole keeps moving, silent, indifferent, growing heavier with every desperate attempt to stop it. And yet, something has changed. Humanity has seen its own reflection in the void. The scientists stop shouting and start listening. The black hole, once just a monster in the sky, becomes something else, a mirror, showing us the limits of what we understand. Every theory, every wild experiment has brought one truth closer to the surface: the universe doesn't play by our ambitions. It plays by rules we barely grasp. On the final night before the black hole's closest approach, the world is quiet. Cities dim their lights. People gather outside and look up. The sky looks normal, but everyone knows it isn't. Somewhere out there, just beyond sight, is the end of everything, and somehow that realization feels calm. News anchors no longer promise solutions. Scientists stop pretending they can fix it. The last transmissions from mission control are not commands, but messages of wonder, fragments of data, beautiful equations, strange radiation patterns that rewrite what we thought we knew about space and time. And then, as the black hole glides past Earth, the instruments pick up something unexpected: a signal. It isn't human, it isn't alien, it's a pulse, soft, rhythmic, almost like a heartbeat. The last ship that disappeared into the event horizon might have triggered something inside. Maybe a reaction, maybe a message. But before anyone can decode it, the signal fades. No destruction, no salvation, just silence and survival. The black hole continues on its path, leaving behind a scar in the night sky and a question that will haunt generations: did we change it? Or did it simply choose to ignore us? In the end, the story isn't about winning or losing. It's about understanding what impossible truly means. Humanity aimed its brightest light into the darkest place in the universe, and for a brief moment, the darkness blinked back. Maybe that's what progress looks like. Not victory, just the courage to look into the abyss and keep asking questions. And as the narrator's voice fades, one last teaser flashes across the screen. If we can't destroy a black hole, what happens if we fall into one? In the end, the black hole was never the enemy. It was the test. Every rocket, every explosion, every brilliant failure showed something simple but profound: that humanity will always reach for the impossible, even when the universe tells us no. When the sky finally went still, there was no explosion, no miracle. The black hole drifted past, silent and untouched, leaving behind only a faint ripple in the dark and a changed species staring upward. For the first time, people didn't see destruction in the stars. They saw mystery. Maybe we were never meant to defeat the universe. Maybe we were meant to understand it one impossible question at a time. And if that's true, then this was never a story about doom, but about discovery. As the credits roll across the fading image of Earth, One last thought echoes perhaps the most powerful thing we ever created wasn't a weapon or a theory. It was curiosity the stubborn, beautiful refusal to stop asking what if.